All right, let's get started on Similar Polygons, section 8.1. Our objectives are to use similarity statements, find corresponding lengths in similar polygons, find perimeters and areas of similar polygons, and decide whether polygons are similar. Our essential question, how are similar polygons related? All right, recall in section 4.6 that two geometric figures are similar if and only if there is similarity transformation that maps one figure onto the other. So, knowing the transformation, similarity comes from a transformation. Let's take a look at some terminology that we need to know. Ratios, it compares two things. We also have multiple ways to write it. You've got your colon, you've got the word, TO, and then you've got it as a fraction. And then for equivalent ratios, which are the same, have the same simplified form. Let's take a look at the first example. We want to simplify 64m divided by 6m. The m's are in common, so we're going to cross those out. And since the m's are in common in the numerator and the denominator, they cross out. In other words, they divide out. And the 64 and the 6 both have a 2 in common. So the 64 gets divided by 2 and becomes 32. And then the 6 is divided by 2 also, which becomes 3. So our simplified fraction completely is 32 divided by 3. Now let's take a look at our second example where we have a fraction multiplied by a different fraction. We have 5 feet divided by 20 inches times 12 inches divided by 1 foot. We can cross out the feet because they are in common in the numerator and denominator, so they divide each other out. Just as the inches are one in the numerator and in the denominator, we'll cross out as well. Then you're left with simplifying your numbers. So 5 times 12 becomes 60 in the numerator, and then 20 times 1 becomes 20 in the denominator. And then 60 and 20 both have a 10 in common. Actually, more than that, a 20 in common. So 60 divided by 20 becomes 3, and 20 divided by 20 becomes 1. So 3 divided by 1 is as simple as it gets. All right, another term we need to know is proportion, which is an equation that shows two ratios being equal. So let's take a look at this example. A divided by B equals C divided by D. The means are B and C position, so these are your means, and then your extremes are in the A and D position. So to solve proportions, we take the product of the means and set it equal to the product of the extremes, or in other words, we cross multiply. So you can cross multiply the 2 and the 8, and then cross multiply the 5 and the x, getting you 5x equals 16. Continue to solve for x by dividing 5 on both sides, so you get x equals 16/5. Always make sure your fraction is completely simplified. Next example, we have 1 divided by y plus 1 equals 2 divided by 32. Again, we're going to cross multiply, so we get 1 across from 32, which is our extremes. Then you have your means, so 2 times y plus 1. Set it as an equation. Distribute your 2, resulting in 2y plus 2 equals 32. Subtract your 2, resulting in 2y equals 30. And then divide the 2 on both sides, resulting in y equals 15. All right, next we want to talk about corresponding parts of similar polygons. We've talked about corresponding parts of congruent polygons in a previous unit, so it works the same way. Let's look at the two diagrams below. In the diagram below, triangle ABC is similar to triangle DEF. So you can write that triangle ABC is similar to triangle DEF as triangle ABC, and then this symbol here, it looks like a single squiggly line, represents similarity to triangle DEF. A similarity transformation preserves angle measure. Super important. Angle measure does not change is what this means. So corresponding angles are congruent. A similarity transformation always enlarges or reduces side lengths by a scale factor known as K. So corresponding side lengths are proportional. Super important. So let's name our corresponding angles just to start off. So we're saying that A, and remember the order of the letters matters, so A is first in the statement, matching the D that is also first. So that means angle A corresponds to angle D. And then the next letter is B, and then the next letter on the second triangle named is E. So that means that angle B corresponds to angle E, and then our final letter or vertices is angle C that corresponds to angle F. All right, so here we have our congruent statements for the corresponding angles, and remember, corresponding angles preserve measure. In other words, they are congruent. Now let's take a look at our sides, and what are the ratios for corresponding side lengths? All right, our first proportion is side DE corresponds to side AB, which also, going around the shape, BC corresponds to, you stay with the same triangle on the top. So going back to the red triangle, we would say EF corresponds to BC. And then we can say that DF corresponds to AC. And they all have the same ratio. They're all equal ratios. And we're using the letter K to represent the scale factor. So all these ratios for every pair of corresponding sides have the same scale factor. So let's just practice using the following diagram to find the scale factor from triangle RST to triangle XYZ. And the order in which this statement occurs matters. So we're comparing triangle RST. So that means we start with this triangle and we compare it to this triangle. So I've sketched in a green triangle to illustrate and remind me that I'm always starting with this triangle and comparing it to this. So I'm going from big to small. That's important to think about. All right, and then we're going to list all the pairs of congruent angles and write the ratios of corresponding side lengths in a statement of proportionality. All right, start by comparing XY to RS. And its ratio is 12 to 20, which simplifies to 3/5. Now let's compare this ratio to all the other corresponding sides. So next we can look at comparing YZ, side YZ, which is here, to ST, which is here, corresponding sides. So then we have 18 divided by 30, which simplifies to 3/5. And then our last pair of sides, we've got ZX corresponds to RT or TR, and the ratio is 15 to 25, and you plug in the numbers, which simplifies to 3/5. So as you can see, they all have the same ratio. So the scale factor is 3/5. So if I were to multiply 3/5 times every side of the bigger triangle, that will get me the smaller triangle. Next, let's look at all the corresponding congruent angles. Again, order of your letters matters. So we have R first, then we have X first. So R corresponds to X. You can also look at, if you don't know, if you're not given a statement, a similarity statement like this one, you can always look at your picture. And we've learned about looking at side lengths and telling which angles are the smallest and which angles are the largest. So for this bigger triangle, RST, the smallest angle is across or opposite of the shortest side. So angle T would be the smallest. And on the smaller triangle, the smallest or shortest side would be 12, so Z must be the smallest angle. So angle T and angle Z are the corresponding angles. So you can go all the way around the shape and do the same thing. So we can say that angle R is congruent to angle X, angle S is congruent to angle Y, and angle T is congruent to angle Z. And then part C, writing the ratio of the corresponding side lengths in a statement of proportionality, super important, another kind of vocabulary word to recognize. looks like this. So we've already figured out the ratios in part A, so use those same ratios to write your statement of proportionality, which is what this looks like. So after looking at that example, here's another core concept. When you're finding corresponding lengths in similar polygons, your corresponding lengths, if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygon. And this includes any parts of the figure. So if we're looking at similar triangles, it would include side lengths, altitudes, medians, mid-segment. So any part of any figure counts as similar in when you set up your proportion statements, in addition to figuring out your scale factors. So let's take a look at this next example and find the value of x, knowing that triangle DEF is similar to triangle MNP. First, knowing that the triangles are similar means that we can conclude that corresponding side lengths are proportional. So start by writing a proportion. We can say that MN, side MN, corresponds to side DE and is equal to NP, which corresponds to EF. Make sure that you note the two sides that are in the numerators come from the same shape. And then the two sides that are in the denominator come from the same shape. Super important that you maintain consistency within your proportion. Next, you would substitute the side lengths that you're given. So we know that MN is 18, so you substitute 18 in the numerator. We know that DE is a length of 15, so we substitute 15 in for DE, equal to, knowing the length of NP is 30, and then EF is what we're trying to figure out, so that's our x. Next, you want to cross multiply, so you've got 18 times x equal to 15 times 30. So our cross products property results in 18x equals 450. Divide both sides by 18, resulting in x equaling 25. So the value of x is 25. All right, third example, let's look at the diagram. Triangle TPR is similar to triangle XPZ. Find the length of the altitude segment PS. So notice you have two shapes that are sharing the same vertex, vertex P. So it's good to get orientation, and when shapes are not side by side with the orientation the same, it's always a good idea to just re-sketch your picture to where all parts, corresponding parts, are just side by side. So first we're going to look at the scale factor. What number do I need to multiply times any of the sides of triangle XPZ in order to obtain the side lengths of triangle TPR? So notice that you're going from large to small. So that means we have a smaller number, less than 1, having to go from big to small. You can pick any corresponding sides to set up. Let's look at TR, which we can see by our diagram here. 6 plus 6, which would be 12. Corresponds to XZ, which would be 8 plus 8, which is 16. So we have 12 divided by 16, which simplifies to 3/4. You always want to simplify your fractions. Always, always. Now, because the ratio of the side lengths of the altitudes in similar triangles is equal to the scale factor, you can write the following proportion. PS divided by PY equals 3/4. You can substitute 20 for PY. You have PS divided by 20 equals 3/4. So you can multiply both sides by 20. So you get 3/4 times 20, which simplifies to 15. So the length of the altitude segment PS is 15. All right, your turn to try these two. So pause the video and try these on your own. All right, for number 2, x equals 8. And for number 3, km equals 42. All right, that's all for this video, part 1. 8.1, section 8.1, part 2 will continue tomorrow. All right, see you in class.